Fantastic. Show how to declare an integer variable named I. Ready? There. And set its value to 7. There. Now, can anybody do it in one line? Int I equals 7. There you go. Incidentally, besides integers, what other types do you have to work with? There's one called a double. A double can hold values like 159. That is exactly equal to pi, by the way. Yes, I've memorized it off to that many digits incorrectly, apparently. There's something called a char, where you put a letter. Float is just like a double, except it doesn't remember as many decimal places. So why would you ever use a float instead of a double?
You don't want that many decimal places.
Yeah, the short answer is never use floats, always use doubles. That's my opinion. Floats are slightly faster. So if you're writing a high-performance graphics application, you might want to use floats instead of doubles. There are some valid reasons why floats are still supported. But in general, if you're going to do some math, you'd rather have accuracy, right? And computers these days are blazing fast. So in my opinion, just always use doubles and never use floats. But floats do exist. There's also a thing called a short, which is just like an integer, except it doesn't hold numbers that are as big. In my opinion, never use shorts. Almost nobody does. But again, there's valid reasons for them. They take up slightly less memory, which almost doesn't matter these days because computers have crazy large amounts of memory. So short doesn't exist as far as we care. Short, char, what else is there? There's one called byte. A byte holds a number from 0 to 255. You probably won't use bytes a lot. Forget about those two. Those are some of the main primitive types in Java. Okay, any questions? Moving on. Show how to increment an integer variable. First of all, let's assume we already have an integer variable, like that. How do you increment it? I++ or ++ I. Either one will increment I. Or you can say I equals I plus 1. Any of those three will increment I. Now, yesterday I mentioned that you could do both of those, and I kind of hinted that there is a subtle difference between them. Would you like to know what the subtle difference is?
Yeah.
Okay. It turns out that these operations actually return a value. Now, usually we ignore the return value because we just say I++, and whatever number it gives back to us, we're not even using it. But you actually can, if you want to, say if I++ is equal to 7, then system.out.println, I don't know what to type, cat, else system.out.println dog. Okay, will this print cat or dog? Any guesses? It turns out this will actually print cat. And you might say, why? And the reason is because the I comes before the ++, and so it returns the value that it had before it incremented it.
So the ++ ahead of the I would actually increment it beforehand.
That's exactly right. If you say ++ I, now it will print dog. But if I were to change this to an 8, then it would print cat. So why on earth is the thing you might ask. The main reason this exists is so that they can ask you about it on the praxis test. I think. I can't think of a whole lot of other great reasons for it other than to confuse people. Okay, I jest. There are some valid reasons for it. It turns out that both cases are often needed in programming, and the shorthand does save keystrokes. And as we all know, human programmers have a limited number of keystrokes. As soon as you run out, you can't type anymore. So saving keystrokes is important, I guess. Basically, if the plus plus comes before the variable, it returns the value of, well, if the variable comes after the plus plus, it's going to return the value after it was incremented. Either way, I is going to have the number 8 when we're down here. Okay, so to be clear, system.out.println I. If I write code like this, I++ equals 7, it's going to say cat 8. Does that make sense? At the moment it does the comparison, it's comparing with a 7 because it's not comparing the value of I, it's comparing the value I had before it was incremented. But when I print I, it's an 8. And if I say ++ then it's going to say dog 8. And if I do that, then it'll say cat 8. You with me? Okay. Not a really critical thing for programming, in my opinion, but it is a detail that will inevitably come up, so it's something you want to be aware of.
So, just to clarify, ++I would reveal cat 8.
Let's see. ++I, if the code is written as is,
Okay.
then this operation will return the number 8, which is equal to 8. So it will say cat, and then it will print an 8 right there.
Okay.
So yes, this will say cat 8.
But if it was I++, it would say dog.
This will actually say dog 8. The I is still incremented, so I becomes 8. But the if statement is comparing a 7 with an 8. Because it's not actually comparing I, it's comparing I++, which is what I used to be. In other words, here's what it does. It increments I, but this whole expression evaluates to the old value, not the new value. Okay. Does equal do assignment or comparison? You had a 50-50 chance. It is assignment, which means it sets it. It sets the value. In Pascal, I think they use colon equals to do assignment. And in some languages, they use less than equals or less than or minus. That's kind of more explicit in my opinion, because that takes the 5 and puts it into the I. But C++ and Java are very popular, and they use a single equal sign. So that's what the world has pretty much standardized in programming. Okay, if you got 5 right, this one was kind of obvious. The answer is comparison. When do you do comparisons? I can think of really only 2 places. If statements, you can say if I is 7, then do something. System.out.println. Yep, I is 7. I is 7. Oh, that sounds like horrible grammar. Doesn't even make sense, but okay. It's bothering me for some reason. I teach my children to be grammar Nazis, and they're terrible. They correct me all day long. Let's see. Did you know? I forgot a primitive type when I was telling you about it. There's another primitive type called Boolean. You can say Boolean, B equals I equals 7. And then I can say if B. And this actually does the exact same thing as the code did a moment ago. A Boolean value holds either a true or a false. And it's a true if this thing is true and a false if that thing is false. So this whole expression here in parentheses evaluates to true or false. Right? Any statement with a comparison in it basically becomes a true or false value. And you can store that value and use it in an if statement if you want. So whenever we say a comparison, that's kind of equivalent to saying a Boolean value. And you can substitute a Boolean value for a comparison because all comparisons evaluate to a Boolean value. All right. That's all I can think of to say about that. What other kinds of comparisons are there? Equals, less than, greater than, not equals. I think that's the next one. Okay, there you go. Not equals. There, we answered that one. I never taught you that one. This was an unfair test question, but this is testing whether or not you read ahead and look outside of the lesson. And now you know whether or not you do, as if you didn't already. Double equals less than, greater than, not equal. Oh, there's less than or equal to, greater than or equal to. And we'll say that's good enough for now. So these are the main comparisons you do. The bang equals is supposed to look kind of like that equal sign with a line through it, you know, that you use in math class. It doesn't really look like that, but you're supposed to use your imagination. In BASIC, they use the less than greater than symbol to indicate not equals to. I kind of grew up thinking that was what not equals was, and when I switched to C, it was a pain for me to learn this one. But bang equals is the new standard not equals to, so forget what I just said and pretend I didn't say it at all. There you go. And no, you can't just say equals less than. That doesn't work. You have to do less than or equal to, because somebody said. What is the symbol for or? Double pipe. Yep, it's the vertical bars. Now, somebody told me you can actually just type the word or. And I tried it in my class 1 year and it worked. So maybe in some compilers you can. But then I went back to my office and tried doing it thereafter and it stopped working. And so apparently certain versions of Java support or instead of pipe. I recommend always using pipe because it's very standardized and it has been working for years. I think or might be somebody's great idea of, hey, why are we using symbols anyway? Why not just type it out? Which makes a lot of sense, but I don't think it's yet firmly established. Probably in the future of programming languages, they'll be more intuitive and less symbolic, but for your knowledge, pipe is the right way to say or.
Were they mostly symbolic in the past just to save memory space?
Probably, yes. Long ago, we didn't have much memory. We didn't have a lot of space. Plus,
My 64K Atari?
yeah, exactly. I grew up on a 64 Atari 800 XL. I spent so many hours just tinkering on that little thing. And then my dad sold it at a garage sale. I was so mad. Probably be worth something these days. Okay, what is the symbol for and? Double ampersand. Now, here's something I should point out. There is such a thing as a single pipe or a single ampersand. And this is another detail that they might try to pick on you on the practice test. So let me point this out. Anybody know the difference? Okay. The single operation is a bitwise logical operator. Do you know about taking bits and doing AND operations or operations? You know about logic gates? Well, that's what the single pipe does, or the single ampersand, is it does a logical bitwise operation. So if you have the number 101101101 and you OR that with 00110011, the OR of that is 1011011111. Basically, if either this one or that one is a 1, then the bottom gets a 1. This is called a bitwise logical OR. Let's do the same thing with AND. Okay. The AND of those two numbers would be 001100001. Right? Only if the bottom and the top are 1s, then this one gets a 1. Why would you ever want to do this? Chances are you're not going to want to do it for some time, but if you're actually trying to manipulate the bits in a number, which sometimes you do in computer science, then you'll want to use these logical bitwise operations, and that's what they're there for. They did a lot of that back in the days of having 64K of memory because manipulating bits is the most efficient way to store data. These double pipe and double ampersand are for conditional statements. So I say if A is equal to 5 or B is less than 72. And what it does is it evaluates the first condition. And if that condition is true, it doesn't even waste its time evaluating the second condition, because why bother? We know that this one's already true, so the condition must be true. Similarly, if we do the double ampersand, it evaluates this first one, and if that condition is false, then it's not going to waste its time evaluating the second operation, because the first one's false, there's no way they're both true. So this is the one you're going to use a lot because you use it in conditional operations. And that's the end of our test. Okay, how do you feel about yourself? Are you keeping up? Doing okay? Did you learn anything just now? Good.